Now tell me one thing, that do we ever think that why do we see a water droplets on the outer surface of a glass while containing a cold water? Hello, my name is Gaurav and today we are going to discuss a very important topic of geography, that what humidity is and into how many methods can we measure it. So let us start. Now the first question is that what is the humidity? So if we'll go with the basic definition of this term, so it is the amount of a water vapor present in the air, यानी कि हमारे आसपास उपलब्ध हवा में उपस्थित जल वाष्प की मात्रा को ही हम आर्द्रता कहते हैं. So this is the most generic definition of this term. Now if somebody is going to ask you that prove that air has a humidity or air has a water vapor, then what will you do? So सबसे पहले हम एक स्टील की ग्लास लेंगे, उसमें हम ठंडा पानी डालेंगे और थोड़ी देर बाद देखेंगे तो देयर आर सम वाटर ड्रॉपलेट्स अटैच्ड टू दिस आउटर सरफेस ऑफ अ ग्लास. तो सपोज दैट दिस इज अ ग्लास, ये एक टेबल पर रखी हुई है और इसके अंदर ठंडा पानी है. दिस इज अ कोल्ड वाटर. अब चूंकि ये ग्लास ओपन में रखी है तो इसके सराउंडिंग में एयर होगी एंड दिस एयर हैज ऑल्सो सम वाटर वेपर कंटेंट. अब मान लेते हैं कि इस कोल्ड वाटर का टेम्परेचर 5 डिग्री सेंटीग्रेड है और जो आउटर सराउंडिंग है यानी कि इस एयर का जो टेम्परेचर है एटमॉस्फेरिक एयर का वो 35 डिग्री सेंटीग्रेड है. तो जैसे ही ये जो वाटर वेपर के कंटेंट हैं ये जैसे ही ग्लास के कांटेक्ट में आएंगे, बिकॉज ऑफ द condensation process, these water vapors are converted into a liquid water, or you can say that these are the water droplets which are settled around the the outer surface of a glass. तो ऐसा तभी कंडेंसेशन प्रोसेस हो रहा है, इसका मतलब है कि there are some water droplets in the air. Okay, so this is the definition of a water vapor. Okay, now we are going to understand that into how many methods can we measure it. Okay, so first method is the absolute humidity. Now listen it carefully. See, this is the amount of a water vapor present in the given volume of a air. So here the word volume is important. Okay, now if I will write down on a board, so absolute humidity is the amount of water vapor present in the given volume of air. Okay, now if the mass unit of water vapor is gram and the unit of volume is centimeter cube, then what will be the unit of absolute humidity? It is gram per centimeter cube. Now you need to know here that temperature is going to play a very important role. Why? So let us see. Suppose that this is a given volume of air. Let us take it 10 centimeter cube and there are some water vapor content inside this volume of air. So let us take it 5 gram. Then what will be the absolute humidity here? It is 0.5 gram per centimeter cube. Okay, now if this volume of air will expand because of some temperature rise and it will become 20 centimeter cube, but the water vapor content is same, that is 5 gram, then what will be the absolute humidity? It is 5 by 20, that is 0.25 gram per centimeter cube. So as you can see here, that absolute humidity is completely changed. So it is why? Because of temperature rise. So now we can say that the temperature is playing a very important role in deciding the absolute humidity of any region. Okay, so to overcome this problem, another type of method came, that is the specific humidity. So what is the specific humidity? So it is the ratio of the amount of water vapor present in the 1 kilogram of air. यानी कि 1 किलोग्राम अगर एयर है तो उसमें जितना वाटर वेपर कंटेंट होगा उससे हम उस एयर की स्पेसिफिक ह्यूमिडिटी को निकालते हैं, ठीक है ना. सो now here as you can see here, that temperature is not going to play any role. Why? Because mass is same everywhere. Okay, so this is the all about the specific humidity. Now come to the another type of method, that is relative humidity. See, this type of method is very important because only after this you are able to understand the process of a rainfall or the occurrence of a precipitation. Okay, so if we'll go with the basic definition of this term, so at a given temperature, it is the ratio of the amount of a water vapor present in the air to the capacity to hold water vapor in the air. Okay, now suppose that in this room 50 gram of water vapor is present, but the capacity to hold the water vapor is 100 gram. So what will be the relative humidity? It is 50%. So we can say that presently in this room the relative humidity is 50%. Okay, now one more thing you need to know, that this capacity to hold the water vapor is directly proportional to the temperature. If the temperature is high, it means the capacity to hold the water vapor is also very high. On the other hand, if the temperature is low, at that time the capacity to hold the water vapor is also very low. Okay, so to make it more clear, let us draw a table. This is for a temperature, this is for a water vapor present in the air, this is for a capacity to hold that water vapor, and this is for a relative humidity. Now suppose that this is a surface of Earth, and because of the heating from the sun, the temperature of the surface of Earth is 40 degrees centigrade and the amount of water vapor present is 50 grams. See, this is constant everywhere. Now as you know that if the temperature is high, the capacity to hold the water vapor is also very high. So let us take it 200 gram. Now what will be the relative humidity? It is 25%. Okay. Now because the surface, if the temperature is high near the surface, so the air around the surface is also warm, and warm air is light, so it will go up. So if this air will go up, so this will expand, and because of the adiabatic cooling, the temperature got decreased at some height. So as you know that if the temperature is low, the capacity to hold the water vapor is also low. Now what will be the relative humidity? It is 33%. Now again, if this air will go, there is an ascendance, the temperature again got decreased and capacity to hold the water vapor also decrease. Let us take it 100 gram. Now what will be the relative humidity? It is 50%. Now as you can see from here that continuously this is decreasing, while decreasing temperature, this is also decreasing, but the relative humidity is increasing. Okay, now if there is a further ascendance of air, so at 10 degrees centigrade, the capacity to hold the water vapor will exactly equal to the amount of a water vapor present. So under that condition, relative humidity will become 100%, and now the air got saturated and condensation process started. So the temperature at which the condensation process started is called a dew point, and finally the water vapor content converted into a water droplets in the form of a clouds. Okay, so this is a topic of humidity, and after this you are very easily able to understand the process of a precipitation. I hope you like my session. Thank you very much.